Hi, it's Keegan Tosh here. Um, Signing on. So for this assignment, I decided to take a closer look at the closer look section, uh, called the wind chill factor, um, in on page 140, in Earth's weather, um, chapter. I sorry. I chose this portion of the text because I felt it. I just feel it's very interesting. It's a word we hear all the time, and I never really connect it to anything. Like I hear wind chill, and I'm just like, oh, it has something to do with cold and the wind, and that's as far as it goes. But I really like looking into the history of things, and this is the history of that term and how it's kind of helped. And so I felt that was very cool. So basically, it talks about how the Arctic explorer Paul A. Sippel, in the 1940s, conducted experiments using a little can, full of water, and putting it at different heights and seeing at what point it froze. Um, so they decided to start using that, and they developed an equation for that known as the wind chill factor. Now, he was doing it at heights of like 10 meters. Um, so like very specific heights, but we now, like, when you hear a wind chill, when you hear the wind chill is this degree, um, it's actually at 1.5 meters since the 2001 National Weather Service changed the method of computing because 1.5 meters is more accurate to the human height. Because the wind chill factor changed from wind chill, like freezing water, to freezing a person. And it's now also factoring in the frostbite, the dangers of frostbite. So it's more accurate now. Um, uh, so basically, it just wants us to. This section of the text wants us to remember that, um, like, what wind chill is and why it's happening, or like why it's important. Like, because wind can freeze things as much as any, you know, lack of heat, uh, because it's pushing away that heat and taking it away, stealing it. And so that's really important because our bodies, like, they radiate heat, and when we're in a still sort of air, that um, lets off. Our bodies are constantly radiating heat, lets off heat, and it can heat the air around us, causing a like cushion of warmth for ourselves. But when the wind comes along, that cushion is gone, and that's why it can be dangerous. Um, um, and the reason I find this so cool, and also the reason that something that could help you remember this is igloos. So, like, why igloos work. It always intrigued me, like, because I like hiking, I like exploring and going up mountains, and I've made plenty of igloos in my life. Not specifically exploring, but just because I could. And it was always interesting because it's very warm in an igloo, and you kind of ask yourself, why? Well, because the ice actually traps the heat. And above that, the wind can't take it away. So, like, wind is blowing around the igloo and not past you, which allows that cushion of heat to stay. So that's why igloos are helpful and why we should learn about the wind chill factor. Thank you.